LEDs are always fun to play with, and I recently added them in this space so it is well lit. But the only problem is that they are just way too bright in the night time, and I want to use them as a night light for this hallway. So let's see how I made an LED dimmer. The type of LEDs I am working with requires 12 volt at full brightness, which means if I simply add a buck converter in between, then I can lower the voltage, which means I can dim the LEDs. Easy, right? Probably not. This type of buck converter can handle a maximum of 3 ampere with active cooling, which I do not plan to add, and the LEDs which I am using also draw about 3 amperes at its peak. But this is not an option because the efficiency of this buck converter is around 50 to 60%, which is not that great. For such application and higher efficiency, we use a technique called PWM, which stands for pulse width modulation. As the name suggests, width of the pulse defines the average voltage. That means if the 100% pulse width defines the 5 volt, 75% will define 3.75 volts, 50% will define 2.5 volts, and 25% will define 1.25 volts. For generating a PWM signal, we can simply use an IC555 timer along with some other components like resistor, capacitors, and a potentiometer. Firstly, I mounted the circuit on a breadboard, and you can find all details about the schematic in the video description. Once I was sure that this circuit works, I made an PCB layout for it and uploaded the Gerber files on JLCPCB.com, who are also the sponsor of this video. You can order 10 2-layered PCB only for $2 from their website. They not only provide 2-layered PCB production but also 4-layer and 6-layer PCB. Production time for 2-layered PCB is only 24 hours. Check them out, link is in the video description. Once I received the PCB, I simply mounted all the components and soldered them. And just in case if you are wondering why I chose to go for PCB, then I will be using this same circuit in my future video, so stay tuned for that. This circuit just works fine, but IC555 can handle a maximum of 200 mA. That's why I left an output pin in my PCB so I can add an external MOSFET at the output. I could have made these changes in my PCB, but a different MOSFET can have different package, so I kept it that way. So finally adding this circuit to my LEDs, this project was complete. If you enjoyed this video, don't forget to hit that like button, share this video with your friends, and subscribe for more awesome content like this, and I will see you guys in the next one.